the D sharp. But with these new alternate lines of symmetry, this one is just like the D, the G is part of the parent scale. And then for this one, just like the D, the A is part of the parent scale. And the interesting thing is that in the circle of fifths, A, G, and D are very much related. If you're playing in the key of A, then you are covered to go to D in the same way that we were playing in the key of C, and we play A minor chord, we play G chord and F chord. They're all very much at home in the C major scale. If you're playing in the A major scale, you're very much at home with D major chord in the family, and D, if you're playing in D major scale, you're very much at home with A. Also, if you're playing with G, you're very much at home with D, and by the time you go to D, it's related to the A major scale. And then, well, A is more related to D, and then D is more related to G than A, but it creates a circle of connectivity. Now, we have here C sharp. That doesn't belong in the C major scale family or the A minor scale family. And then we have E flat. That doesn't belong either. And then we have G sharp. Where are they? Well, we've played around with G sharp. Then we have C sharp and E flat. Now, interesting thing is that we've established G sharp. So, what about the C sharp? C sharp, that goes with blues. So it depends on which pentatonic scale you're playing. If you're playing the one with F, G, A, C, D, where is that? Where is F, G, A, C, D? Oh, I see it. And C sharp is in the line of symmetry. In the same way that G sharp is in the line of symmetry of and then let's see where the E flat is. The E flat, we have D, E, G, B, D, G. Where can we find that? Well, we have D, E, G, A, B. And sure enough, E flat. So, this C sharp gives a bluesy feel to this pentatonic. Pentatonic goes like this. That C sharp will give some bluesy flair to it. And also, for this one, the E flat will give a blues flair to it. And same here like this one, the G sharp. Now, being that all of these other pentatonic scales fit into the C major scale, and by their lines of symmetry, they draw in the C sharp and the E flat. The question is, will the C sharp and the E flat bear the same kind of significance? I doubt it though, but anyway, they will have some, but not the same significance. Will they bring worthwhile significance like the G sharp does? The G sharp brought significance by making this more bluesy. It brought significance by bringing in augmented, diminished. It brought significance by changing the A minor scale into something more Middle Eastern and some classical feel. So, what can we do to test it? Well, let's play the C major scale and throw in E flat somewhere. You know, I mentioned that there is the scheme of the modes when you are playing in C major scale. There are various modes: Dorian, Locrian, Phrygian, Ionian or Iolinian. Anyway, I don't know them by name. I have such ease with doing this kind of thing to throw in and find variations that I don't really miss them. So, you know, never really had so much composing, never really bothered much with trying to learn all the scales and their names. You know, I was just ending up doing them by proxy, finding them on my own because I had a method of exploration that worked. And let me clear this up now. This method, I didn't start with this method and then learn how to play. What I did was I learned scales, I learned chords, and I practiced and I pounded scales, you know, until I could run them. And I can play better than what you're seeing here. I played for many, many years before, you know, doing this. I've been playing piano for over 20 years now, but I've been doing this for probably well, the first time I ever tried anything with it, you know, was probably 14 to 15 years ago. I probably first thought about it 16, 17 years ago and didn't really start drawing things out and seeing that there was more to it than just, hey, I drew a few chords in there and they look cool. No. I started seeing more probably about 14, 15 years ago, and then really started exploring and delving into it probably for 10 years, and been looking at it and following up. Most of that time was spent not even, you know, exploring this or doing anything. I did have a period of 3 or 4 years where I did some intense research using libraries and checking out other people's stuff, but most of this I just had to come up with it on my own, but not learning to play via this. I learned how to play first here and then translated what I knew about music theory into this. I already knew the C major chord, the C major scale, and went ahead and drew it in here, and then to see, wow, it's got a line of symmetry. Oh, and then I already knew the C major chord and A minor chord, and then fit that in there and saw, oh, well, they line up around it too, and went on, and even beyond this. I'll keep bringing diagrams. I have some that don't even look like this. They're not about the circle. They're doing arithmetic tables based on the number of black notes and number of white notes per transposition of scale. So, like for instance, in this scale, 1, 2, 3, 4, 5, 6, 7, there's 7 white notes and no black notes. The next one is there's 5 black notes and 2 white notes, and on and on and on. And so when I write C scale in terms of 7 white notes and 0 black notes, okay, and then go to the next scale and write it in terms of 5 black notes and 2 white notes, and then the next one you get 3 and 4, and then the next one you get 4 and 3, and then you get one that's 6 and 1, and then you get one that's 5 and 2, and on and on. Well, anyway, a very interesting pattern emerges, and then that pattern emerges with a line of symmetry, and the line of symmetry runs through C and F sharp, defining C to F sharp as the line of symmetry for the chromatic scale, which is this. there's only one way to get your bearing on a chromatic scale. Otherwise, it just runs monochromatic. Probably it just doesn't have any. It's equilateral. It's you could run a line of symmetry through every note and still be okay. So how do you get your bearing on a middle in something that could have its middle anywhere? Well, you get your bearing on its middle based on the subscales that you cut out of it. And so the primary subscale is the major scale. And by the time you plot all the major scales in terms of the number of white notes that they use and black notes that they use, and sometimes like in the C major scale context, it uses no black notes. So you just fit in 0. And you line that up, 12 of them. Put those arithmetic equations, all 12 of them, and when you look at it from top to bottom as one unit, you'll see a pattern with mirror image reflection. You'll see a center line marked by F sharp, and everything above F sharp is a mirror image of everything below F sharp. And these are equations, not shapes. Even the equations show mirror image reflection. You could just ignore the numbers and you'd still see geometry in the distribution of the numbers in standard arithmetic array. But of course it's arithmetic arrangement that's in algebraic fashion, but not using unknowns or whatever. If anything, we know that the numbers are representing numbers of black and notes and numbers of white notes, or sharps and flats and regular notes, however you want to put it. It's quite simple for the parts and pieces, but where they begin to stack up, you can lose track. Even the drawings, if I overlap too many, it becomes hard to point out which one. Right now with just 2, I can point them, and I even shaded this one in this way and shaded that one in that way, and still it's a little bit hard on the eyes. Plus I'm just hand drawing this on the go. I did some nicer ones, and I left them in my bag. I'm going to put together a book, that has the drawings and writing and everything. It's the kind of subject that I can do good with the diagrams. I just don't know about writing everything in right next to the diagram, so I want to try just talking about it on a video and sharing the information. That's about it. There is a guy who put something on YouTube, and I'm hoping to eventually put these on YouTube. Nothing special, just to put them there to be there. Somebody will use the information. I don't expect you to really think much about my video and writing and my oratory skills or all that. But I have something here that works, that you don't find everywhere, and I'm able to explain it. If you can just get through some of my, I don't know what to call it, but I'm not a good orator or an experienced teacher, but I know that what I'm talking about here works, and I'm putting it right before you to see. And this is good for people who are really well experienced with music but haven't really dabbled in the geometric and mathematical aspect of music theory. It's not that hard. It doesn't go much further than the kind of geometry that you do, in a grade school level. And the mathematics doesn't go any further than arithmetic. You might have a complex array of arithmetic, but as far as calculations, no, you're not going to do anything more than arithmetic. And you're not going to add anything up more than 12. Even when you do a few pieces of division, you're not going to divide anything more than maybe 12 by 6, 12 by 2, divide 12 by 3, divide 12 by 4, maybe multiply 3 by 4, maybe multiply 4 by 3, and 2 by 6, and that's it. And then the arithmetic is going to be no more than adding and subtracting things that add up or to no more than 12. And it's because that's all we're dealing with here, 12. So you don't need long division skills and multiplications of 4-place numbers and all of that, or decimals. Nothing. Simple. In the end, this is the kind of math that's wants to go more towards physics, because this is all what sound is doing. And you can't see sound and what it's doing. And this isn't exactly what the sound is doing, but it's analog to what the sound